Wonderful, wonderful. Welcome once again. The journey through the valley of the shadows of research matters. Now, in this journey, we swim. And we swim in a way that even if you are not, or you are drowning, you get somebody to help you. So don't worry. Just feel free. Today, we want to look at applied an example of a hypothesis testing, a one sample. So you are cordially welcome to this beautiful journey. In this journey, we are going to look at the authenticity of claims. People make claims without authenticating it. And we want to see how you can authenticate the claims. You remember last we were just trying to look more at the hypothesis. Different kinds of hypotheses. We went through some of them. You were writing, you were enjoying. Some of them you were excellently running through. Some of them you were drowning, But we still were able to come out clean on the other side. So there's no problem at all with that. Today we want to continue with that. We want to demonstrate the process of hypothesizing, and then how we can conclude with that. So these are the outlines that we are going to be dealing with throughout. Real life, as an example, we are going to use an SME. An SME is a small and medium scale enterprise, and then we use that as part of our example. You will understand what a test statistic is, what a critical value is, what a p-value is, the level of significance, what we mean when we say statistical significance, and what we mean when we say practical significance. So we are going to swim a lot in this whole caboodle. And the reading list is there. Chapter 9 of Anderson, chapter 16 of Bergler, and then chapter 9 of Newbold. All of these chapters are there. In your free time, glance through them. Sometimes you tell people glance through them, then they go home, they sleep. Master, please glance through them and enjoy the enjoyment, so that you can pass with glee. Good. So let's start. The level of significance. Now, if you look at the sign for the level of significance, it is what sign? It's alpha. You see? Alpha. Alpha sign. The level of significance is the probability of making a type 1 error when the null is true as an equality. Master, that looks mumbo jumbos. But let's calm down. You see, when a person is making a hypothesis, sometimes the person will say, I am this % sure that what I'm saying is what? Is true. But it means that the person is not a certain % what? Sure. So if I say that I am 95% sure, it means that I'm what % not sure? 5% not sure. Now that 5% is your expected mistake. That is a mistake you're expecting to make in your statement. But the whole of the 95% is your confidence level that you have in that statement. So I tend to say that the level of significance is the error or the mistake you expect to make in your analysis. But you see, the mistake you expect to make is not the same as the mistake you actually make. So everybody who is doing a research, who is making a project, who is doing anything, is expected to make some level of mistake. So the level of significance is that level of mistake that you are expected to make. And it is given to you by virtue of the nature of the work is given to you. So we shall be given the level of significance. There are different levels of significance, but these are the main ones. 1%. You see, if I say I am 1% having that level of significance, or I'm 1% not sure, it means I have 99% what? Confidence in the whole thing. And that means that you don't expect to make a mistake at all. The highest level of significance that is in the literature is generally 10%. 10%. Okay. So we are going to use examples of the. Please remember the sign for the level of significance is what? Alpha. We shall use that. Once you know the level of significance, you have to compute the test statistic. You see the test statistic I have written here. Let's look at them deeply. We shall come to them again when we are looking at the applied example. But let's look at the first one. The letter that starts from the first one is what? Is T. The letter that starts from the second one is what? Is Z. It means that sometimes, depending on the nature of the circumstances or the research, you have to use a Z test. In other situations, you have to use a T test. When do you use them? Who can tell me? When do you use T and when do you use Z? Yes, Kwesi. Before I give to Kwesi, let me give it to Pearl.
Okay, so we use T when the sample size, that is N, is less than 15.
15? You see the way my is going? Yes, Kwesi.
Doc, I think we use T when our N is less than 30, where N is our sample size.
Good. And then when do we use the Z?
We use Z when our N is greater than 30.
Good. That is a love lie. Very love lie. Okay. So you are very right. You nail it right there. Inside. Look at the next statement. Use Z if sample size is large. How large is large? When it is 30 or more. Use T if sample size is small. How small is small? When it is less than 30. So if you have a sample size equal to 30, you have to use what? Z. But hang on a minute. Let's go back to the formula. To be honest with you, when you look at the formula critically, you can see that there is no big difference between the two formulae, except the sign, which is the numerator sign for the denominator here. The numerator sign here, the top values are the only difference. Where this one is a sample standard deviation, and then the one there is a population standard deviation. We shall look at them. Okay. Let's try to identify the key elements in this formula, by the way. The key elements. Look at the first one. Who can tell us that all the four elements, X bar, mu, S, and then N, can tell us all the elements? Yes. Who will tell me all the elements? Drink deep. Remember.
I'll skip the first one. So T is equal to the first one I don't know, minus mean over the sample standard deviation over the square root of the sample size.
Very good. Very good. So the first mu, okay, the mu that you see here is a population mean, whereas the X bar you see there is the sample mean. So you have the sample mean, which is the S bar. You have the population mean, which is the mu. Please, the word is mu. It's not moon. Okay, it is actually spelled like moon, but it's pronounced mu. Okay. In any case, it's a Greek signs that you can use. So this is our test statistic. What is it for? What is it for? Well, this is where when you put certain things in, it's going to tell you whether your statement you are making is what? Is a right on statement or is not a good statement. Of course, you have to compare this to a benchmark before you can identify that. We shall look at an example on that. The next thing is that to find that benchmark, you need to identify something called degrees of freedom. Degrees of freedom is simply the sample size minus 1. The sample size is n minus 1. Okay, so we will find the degrees of freedom, and then we will use the degrees of freedom to find that benchmark. The benchmark is called the critical value. The critical value is found on the table, the T table, which is online. You can print it out and you can use. That is it. And the T table is used to find the critical value. The critical value, to find it, you need the alpha. You remember what alpha is? The level of significance. And then you will now see where the alpha and then the degrees of freedom will meet on the table, and that is your critical value. Once you get your critical value, you have already calculated your calculated or the t statistic, and then you can now compare the two and then make a conclusion. Another way you can find this is by using what we call the p-value. So please note, the first one, you will have the critical value approach, and then you will have the p-value approach. So let me walk you first through the p-value approach, and then we'll see the critical value approach, and then we'll pick an example, and then we'll do both of them. So the p-value approach, this is what you do. On the table, you will have to go and use your calculated t. So let's say your calculated t is 3. You go and take this 3, and then you use that one to get your p-value. How do you do that? Don't worry, it's a very simple thing. The p-value, let's try to explain what that is. Do you remember we said that the alpha, the level of significance, is the mistake you are expected to what? To make. The probability of committing a type 1 error. What is the p-value? Well, the p-value, I'll put it simply, is the mistake you actually make. You see, the mistake you make is different from the mistake you are expected to what? To make. So the mistake you actually make is the p-value. Which one would you want to be smaller? Is it the mistake you expected to make or the mistake you actually make? Think. This one, drink before you answer. Which one do you think? Yes, Miriam, you want to give me something?
The mistake you actually make should be smaller.
Good. So which one? The p-value should be smaller, or the alpha, the level of significance?
The p-value.
The p-value. You see, she gives the answer with all glee, with all joy. The mistake you actually, who would want to make a bigger mistake? So if you're expected to make 5% mistake and you want to make more than that, no. You want to make small mistake, which is your p-value. So the smaller the p-value, the better. That is a point. The smaller the p-value, the better. So if your expected mistake is 5%, you would want your p-value to be what? Smaller than that. If it is 10%, your p-value should be what? Smaller than that. What a joy. So you see, you reject the null hypothesis when the p-value is smaller than alpha. You reject the null hypothesis. The null hypothesis, your goal in hypothesis testing is to reject the null hypothesis, because that is not what you are making. That is what somebody more or less has made, and then your goal is to do a research to reject it. For you to reject it, you must have smaller mistakes in your analysis than the one who made that statement. The other way to make a conclusion is using the critical value approach. Look at that. The critical value approach, how do you get it? Well, if you are using the t test, and for this purpose of this course, I will be focusing more on the t. Okay. How do you get the critical value? The critical value, you have to use the alpha. You remember we said that, and the degrees of freedom, and then find the critical value, which is sometimes called the tabulated. So you will have a table, and then you pick the critical value from that table. You see, remember I said the last time, example is more efficacious than precept. 1,000 words. How do you even put it? You say that a picture is worth more than 1,000 words. I've been talking. So the best is to zoom into a practicality of the whole thing. Let's get a practical example. Before then, let's conclude. When do you reject the null hypothesis? Only when the calculated is greater than the tabulated. Please, it's the same as when the p-value is less than alpha. Let me go back quickly. When the p-value is less than alpha, you reject what? The null. Which is the same as when the calculated is greater than the tabulated. Again, you reject the null. So both approaches we are going to use. Are you ready? Are you ready? We are going to see how to reject a statement or accept a statement using the critical value approach or the p-value approach. And we are going to use this table here. Okay, so I'll be coming back to this table and we shall use it. You've downloaded it, so you've all having those your tables, and we are going to use them. If you don't have them, to no problem, we shall be using them here. But it's online, you can download that one. Look at the T table. I want to just walk you a little bit through the T table. Everything we have done in hypothesis is there. Is there. Look at it with all eyes. The top part, you have one tail. Do you see that one? One tail. And then below the one tail, you have what? Two tail. And those values you are seeing there are either the p-values or the alpha, the level of significance, depending on which one is being mentioned here. The ones that are inside here are either the calculated values here or the tabulated. Okay, so the top parts here are either the p-values or the alpha. The inside here are either the calculated or the tabulated. And then, of course, on the far left column are which ones? The degrees of freedom. Is written right there, the degrees of freedom. What a joy! What a joy to set the whole scene this way. Please remember, always use the t calculated to get the p-value. And remember, use the degrees of freedom and the alpha to find the t tabulated. So let's get an example right now. A very quick, easy example. Suppose I have calculated my t statistic, which we call the t calculated. And the value of the t calculated is what? 2.66. But I want to find the p-value using this 2.66, which is my t statistic. How do I get the p-value using that? Because the question says use the t calculated to find what? The p-value. This is my t calculated, 2.66. How do I use this one to find the p-value? Well, scan the body of the table. This is a table. I call it a swimming pool. Okay, this is the table. The whole table is here. And this is the body of the table. I'm not talking about the edges of the table. I'm not talking about the edges. I'm talking about the body, the entire body of the table here. I'm going to scan for that value of what? 2.66. How do you get it? So let's start, combing. Look for 2.66 for me. 2.66. 2.66. Now, it's not a small thing, no. 2.66. There is a way to get it. You can see that the thing starts from 0 here on the left, start climbing, isn't it? Going up. So 2.66 should be somewhere as you go to the right side. This is 2.4, 2.602. Do you see that? 2.624. Do you see that? And then when you come down, sometimes 2.6 also comes somewhere here. Do you see 2.626? Do you see that? And then on top here, what is that? 2.660. Do you see that? 2.660. So this is a 2.66 that we are looking for, or the closest value to it. But please be careful. This is closer to 2.66 than the one here, which is 2.602. Even though it's also got what? 6. So this is 2.66. How do I now get a p-value? To get a p-value, you just look up where you found the 2.66, and the p-value will be one of these. One is a one tail, and one is a two tail. So once you know the tail you are using, you just pick that. So in this case, the p-value will be 0.01 if it is a two tail you are using, or 0.005 if it is a one tail. What a joy. What a joy. I mean, if I should tell you to go over this one right now, you will joyfully go over it. No problem at all. No problem. So all that we did, I've written it here for you. This corresponds to 2.660, leading to a p-value of what? 0.005, just as we said. Red on top. Don't forget if it is a one tail or a two tail. Okay, then you can sense it. Do the same for 1%, do the same for 10% for either two or one tail. Example is more efficacious than present. Are you ready for this example? I'm going to let one of you read this example. This is a whole caboodle, man. So please drink. Okay, drink, and one of you is going to walk us through this whole thing. I'm going to ask you petty questions. So please remember, as the person is reading, you are sinking it down into your heart. So that I'll ask you, and then we can see how we can apply this and make a very good judgment. Okay, so who will do the reading for us? One of you is going to do the reading. Yes, mommy. See the way I'm talking with feeling. Read it with feeling.
Okay. Suppose that you are thinking of taking over an SME. The current owner claims the weekly turnover of each existing SME is not different from 5,000 Ghana cedis, and at this level, you are willing to take on the SME. You would be more cautious if the turnover is below this figure. You examine the books of 26 SMEs chosen at random and find that the average turnover was 4,900 Ghana cedis with standard deviation of 280 Ghana cedis. What would you do?
Thank you. I like that question. You see, the question, what would you do, is not black, it's in red color. It tells you, what would you do? Now, let's go back to the story. Please, when you are trying to do hypothesis, try and understand the preambles. Put yourself into it. Who is the owner? You. You are the owner, okay, of an SME. Or somebody is the owner of an SME, and you are thinking of buying that company. Will you buy the company? Well, the person is telling you that the turnover you will get if you should buy the company is what? 5,000. Look at it. You see the word here. He says the turnover you will get is not different from 5,000. You see that sentence? It's not different from 5,000. Meaning what? It is 5,000. See, sometimes the way some of these things. And at this level, you are willing to buy it. You want to buy the company because you will get 5,000 profits per year. Fair enough. But if it is not, what will you do? You'll be very cautious to buy. So what you decide to do is that you want to sample some SMEs in Ghana, so that you want to have a feel of how much turnover they have been getting. And if it happens that most of them are getting above 5,000, what will you do? You buy this one, won't you? So you did 26 SMEs, chosen at random. So you didn't go and choose the SMEs in Accra alone. You know, randomly sample the SMEs. Down there in those villages, you go there, and then you now put all their annual turnovers together, and on average, you got 4,900 with a certain deviation. The deviation here, the standard deviation here, is talking about, how it slightly deviates from the center on average. What would you do now? Okay, I want you to use gumption, normal human thinking. What will you do? Will you buy the company, given what we are seeing here? Even before we do statistical testing, will you buy it or you won't buy it? Please think and tell me. Will you buy the company or you will not buy the company? Be careful though, because I'll ask you what? Why? So before you tell me I will or I won't, I'll tell me why you will or you won't. I see some of you are just smiling into yourself. Will you buy the company?
I'll buy the company.
Why?
Now, looking at the 26 that have been sampled, if the average turnover is 4,900, and I'm looking at the one I'm buying, which is 5,000, on the face of it, I think I'm better off buying. So that is why I'll buy the company.
Okay. Look, if you are confused, say I'm confused. If you are not confused, then you don't say any other answer. I tell you what, on the surface, you shouldn't buy it. On the surface, because 4,900, whichever way you look at it, is smaller than 5,000. Just going by the average on the surface. Because you will be more cautious if the turnover is below this figure. And the turnover you got on average is what? is below. You see, the issue is not about, oh, it will happen that some are more and some are less. You are not bringing that into the picture. The clear picture of what you are saying is that the average turnover is 4,900, and you can't go for that because it's still below, on average, is below this one. So on the surface, you should not buy it. But is that what statistics is saying? Let's see. Let's put this thing to the fire. The first thing I want us to do, okay, is to identify the key variables in the question. Okay. So I want you to tell me which one is the mean, the population mean, which one is the sample mean, which one is the sample standard deviation, which one is the sample size. Let's get each one of these clear in our mind. And as you get them wrong, I correct you so that you will see which one is and how to identify any one of them. So let's start. Who can tell me which one? So you tell me which one you want to tell me. Who can tell me which one you want to tell me? The sample mean, the population mean, the sample standard deviation, and then the sample size.
Doc, I would like to point out the sample size, which is 26 SME. So the sample size is 26 because he randomly selected 26 out of the total number of SMEs available. So the sample size is 26.
You said he randomly did what?
He randomly selected 26.
Good. Very good. That was very good. Now let me tell you why that was very good. Because you use a certain word, collected. Sometimes you can have selected, chosen. You know this one use chosen. So those are the key words that will help you to know what? The sample size. Chosen, selected, collected. Because we tend to collect these, choose this, select them. And that is the sample size. So N, which is the sample size, equals 26. Which one else is what? Which one else do you want to talk about?
The sample mean is 4,900.
Why?
Because that is the mean that was obtained from the 26 SMEs. The average that was obtained. Yes, from the 26 SMEs. Then the population mean is the 5,000.
Why?
Because that is the average turnover that was given for the SME you are supposedly supposed to buy. Good. In fact, I like that. And I like that a lot. Let me tell you why. How do you separate the sample mean from the sample size? How do you distinguish between the two? Let me give you a clue. And this is always a very good clue. Please take it from me. That the sample mean will always have the standard deviation following it. You see, 4,900 with a standard deviation of 280. You will always have the standard deviation following the sample mean, but you will never have a standard deviation following the population mean. Why? Because the population mean is a statement being made authoritatively, isn't it? By someone who has knowledge of the area. In this case, the current owner. You see, by him telling you that it's 5,000, he has what? Knowledge of the area. So he doesn't need to have any deviation from that statement he's making. But you, who is going to collect, because you don't have much knowledge, you will have what? A standard deviation from the mean. So the standard deviation will always be following the sample mean, but never the population mean. You see, sometimes the sample mean and the population mean will be so close, but still you should be able to identify the difference between the two of them, because one will have a standard deviation following it, another will not have a standard deviation following it. What a joy in really trying to find. Now let's look at your answers now. You see, 5,000 for the mu, which is a population mean. X bar, which is a sample mean. N was your 26. The sample standard deviation was obvious in the sentence. It was 280. And then the alpha is 0.05. Please, let's go back to the question. You realize that alpha was not given. So how did we know that alpha
is 0.07, 0.05, because whenever the alpha is not given, the standard default alpha is 5%. If it is not 5%, you will be told. But if you are not told, always assume that is what? 5%. We have all our variables now. We are now ready to formulate the hypothesis. So let's go back to the beginning. In the story now, you are going to formulate the hypothesis. Please remember, you will not use the sample mean to formulate the hypothesis. You use what? The population mean. I want you to try that and tell me the null and the alternative hypothesis after you've done all your mental gymnastics. Yes, Kingsley.
Look, the null hypothesis is such that, that is column.
Wait. Let me write it.
Okay.
No, you finish.
All right. The null hypothesis, column mu equal to 5,000 Ghana cedis, and the alternative column mu not equal to 5,000 Ghana cedis.
Good. Let's see. Any other answer? Okay. Let's see whether he's right or wrong. I can tell you with all joy again that you are right. No problem. He says that. Let's get back to the question here, because that will help us. Okay. Look at the statement. It's not different from. What sign is that? Equal to. Isn't it? Equal to. It's not different from. So in your hypothesizing, you must have what? Equal to in there. And then you ask yourself, what is the opposite of equal to? Not equal to. So already you are through to go. So let's see how we will write that. Okay. So you will have equal to first. That's what you do. You see, you don't care whether you are writing the null or alternative. You just write the signs down, because they'll bring themselves out. Then opposite of this sign will be not equal to. The first one is equal to 5,000 Ghana cedis. So you put that down. 5,000 Ghana cedis. And then the next one is not equal to 5,000 Ghana cedis. They are all mu's, because this will be equal to and this will be not equal to. Then you ask yourself, which of them has equality or some level of equality? It is a top one, isn't it? Yes. And that is always what? The null hypothesis. The alternative will be the opposite of that in this case. So you have your null hypothesis, you have your alternative hypothesis. Excellent. If you were in an exam, I would just do this. Take A5, answer 5. You have 5 marks. Because you are not just drinking, but you are what? You are drinking deep. You see, when you drink deep, you get 5 marks. But when you drink, drinking without drinking deep, I just do some M1, just give you something. So drink deep, and that is an excellent way of writing it. Once you have your null and your alternative, you see, let's try to put this one in simple English. Simple English means what? It means that the population mean turnover is 5,000. The population mean turnover is not what? 5,000. Very simple. But to be honest with you, take your time here. If you check carefully, you were also told in this very question that you will be more cautious if the thing is below 5,000. You remember? So technically, go back to the alternative. The alternative is saying that it's not what? 5,000. So if something is not 5,000, it means that it can be more or less. So it cannot really be the alternative per se. Because if you are going to be more cautious, okay, you are only going to be more cautious if it is not what the owner is saying. And the owner is saying that is what? 5,000. But will you be cautious if it is not what the owner is saying, like if it is 7,000? So you see the point. So the way this very one has been said is a little bit tricky. So technically, if someone should say that the alternative is less than 5,000, it makes sense. Because if that is the alternative. So if the alternative is less than 5,000, then you'll be what? Cautious. But if you say that it is equal to, or not equal to 5,000, it could be above, and you won't be cautious. But you want to be cautious. That is what the alternative is saying. You want to be cautious. So if a person writes less than that, and once you make this one that way, then it means that you have to make this one what? Greater or equal to. Which then makes practical sense. But to be honest, even though that is what practicality is saying, that is not what was written, isn't it? What was written is not different from. And the word for not different from is what? Is equality. Whose opposite is what? Is not equal to. What a joy. What a joy. What a big joy in starting the whole process this way. So this is your null, and this is your alternative hypothesis. Once you are done with this, your next step is this. Ask yourself, do I use a T statistic or a Z statistic? Who can tell me that? Do you use T in this question? Don't forget the preamble. This is a preamble. Do you use a T or a Z? You use a T or Z? Yes, Miriam.
Doc, you use the T statistic.
Why?
Because the sample size is less than 30.
Good. And is what?
26.
Perfect. The sample size is 26. It's less than 30. T goes. So we are going to use a T. So after your hypothesis, your next thing you want to do is to calculate the test statistic using the variables. Remember, this is a formula for the test statistic. The test T statistic formula is x bar minus mu all over s all over the square root of n. This formula will be given to you in an exams. So in an exams, you don't have a problem writing this one because it will be given to you. But the answer will not be given to you. Okay. So using the formula and then the key variables you have already listed, I want you now to find for me the value of the T statistic. Slot them in, calculate them. Okay. Remember, your x bar is 4900, your mu is 5000, your n is 26, the standard deviation is 280. It could be s, it could be sigma, and we are going to use s or sigma, but we still mean less than 30, and then the alpha is that. So we slot everything in and then find the value of it. Who has finished? You have to work with some speed.
I had the T calculated to be negative 1.82.
Negative 1.82. Excellent. Very good. Very good. Let's see. You slot them in this way, and then you are right as negative 1.82. This is your T calculated. What do you then do with this? You are going to compare it with what? With a tabulated. Don't forget. So this is the T calculated or the T test statistic. Now let's go and find the tabulated, the T critical, and then we can compare the two. Okay. Let's remember the formula you need to find the T critical. You need to know your degrees of freedom, which is n minus 1, and then you also need to know the alpha, the level of significance, which in this case is what? 5%. So you put them down this way. So let's write it down. How you write it is also very important. Okay, so you write T subscript alpha subscript degrees of freedom, and then you put the answer down, which is T subscript 0.05, which is alpha, comma degrees of freedom is n minus 1, which is what? 26 minus 1. Okay, which is T subscript 0.05, comma 25. 25. So remember, this is clear 25. Okay, 25. Let me rewrite it properly. Okay, this is 25. We want the answer, but you see, it says tabulated, so we have to go to where? The table. When you get to the table, don't joke with the table, or otherwise it will joke with you. When you go to the table, remember the tail you are dealing with. Are we dealing with a one-tail test or a two-tail test? Two-tailed table. You can sense that from this, because you have equal to and not equal to. So in our mind, this whole story is a two-tail. Fine. Let's go to the table. In the table here, we are going to look for our value. 25 degrees of freedom in the list. 25 degrees of freedom against 0.05 two-tail. So 0.05 two-tail, you start walking here, 0.05, and then you also look for 25. So when you get to the 25, you start moving to the right, whilst your eye is on the top. Moving to the right, but your eye is on the top, looking for 0.05 on the top. And then still at 25, going, and then you should meet at a value. Have you got a value? I pray you get it. Okay, now let's give it to one of you. Who can tell me the value of the T tabulated? Yes, Per.
The T tabulated is 2.060.
Final answer. That is good. 25. Let's see. Move, and then you have it right there. 25. There you go. Okay, this one, and it means exactly 0.05, and that is 2.064. Perfect. You see, it requires skills to be able, and you can't also find this if you are blind. Do you realize that? So you must open all your eyes, the sockets, and make sure that you are on the right path and they are meeting. Excellent. Finding this answer alone is a very good thing, because that alone, I'll give you another 5 marks. You see, you just write this answer 2.060, and then you get the value that you want. Once you put it down, that is your tabulated. You are ready to go. We have our calculator. Do you remember what it was? It was 1.82 in absolute terms. It's always good to write it in absolute terms. So even though it's negative 1.82, okay, this was our calculated. You can write it as 1.82. Okay, you can write it as 1, and then put that sign across it to indicate that it is an absolute value you are focusing on. So we have our values all found here. We have our tabulated, and then we have our calculated. We are going to conclude. What is the conclusion? Let's not forget. It always says this: whenever the calculated is greater than the tabulated, you reject. I used to dance with that in my previous class. So I remember when I get to the class, sometimes students would say, calculated greater than tabulated, reject. But you see, it was a good song, provided you can what? Remember it. So I remember when students were getting into the exam room, you know, that day of the exam, everybody, calculated greater than tabulated, reject. And then you see the men who sometimes don't learn much, reject. But you see, that is a good thing. For you to remember alone that song means that you can pass. Get the point? So keep it in your mind. There is no magic. Just note that whenever your calculated is bigger than the tabulated, you reject. So are we going to reject this null hypothesis, or we are not going to reject? Easy, eh? Easy. Look at it. Since the calculated, which is 1.82, is not greater, is rather less than the tabulated, which is 2.06, we don't reject the null. So what is our conclusion? We are concluding for the null. You see, if you are not rejecting the null, it means you are accepting it more or less. And what is the null saying? The null said that the turnover is what? 5,000. So we agree with that. Yes, indeed, the turnover is 5,000. So what advice now would you do? Let me ask you now, go back to the original question. Will you buy the SME now? This one is called thinking ability. It's not just mathematics. Now with a full understanding, will you buy the company? Yes, who would tell me? Will you buy the company?
Doc, I'll buy the company.
Why?
Because if we are not rejecting the null hypothesis, then that means the turnover is 5,000, and it was what I was looking for. So I'll go.
I like this. Let me tell you, I like the answer. This is the sort of answers when I get in an exam, I just go for a cup of coffee, and just sip and say, that's my kind of student. You see, these answers, you don't normally get it easy. Will you buy the company? Why not? Look at the next sentence. Nothing prevents you from buying the company. Nothing. Because all you want is all you get. This sort of company, you will buy it and you will buy it again if another time comes, because you are not rejecting the null statement from the guy. The guy was right. You see, I could have asked you the next question. Do you support what the guy is saying? So and this is where you get the highest marks. It's normally 7 marks, because the way you put it is from your own what? Inside, your knowledge. So this is somebody's answer. The person didn't just say, I'll buy the company. You see the way you put it? Nothing prevents you from buying the company. Another person once wrote that I will take the owner for lunch. You see, it just tells you that you are buying it, isn't it? I'll take the owner for lunch. It's a clear indication that you are in full support. What a joy in doing hypothesis. You see, initially, let's not forget, initially, the evidence on the floor looked like we will not what? Buy the company. But when you put the fire onto that statement and trisected it, you can now see clearly how hypothesis testing has helped us to come up with a concrete evidence that we will indeed buy this company. We use a critical value approach where we compare the calculated and the tabulated. But he could be also asked to use a p-value approach. And that is what we are going to do next. Just that. It's very easy. Remember, the p-value approach. How do you get a p-value? Do you remember? You take the calculated and then you drop it, boom, into the swimming pool. And then search the entire swimming pool for the value which is 1.82. So let's go and do that. Let's go to the swimming pool, the table. This is a table. We are going to drop 1.82 into this body of swimming pool and search the whole swimming pool and look for the value closest to 1.82. Then you read the p-value at the top. Sometimes you will get two values, no problem, but they will all be on the same vertical line. So when you trace it to the top to get a p-value, it will be the same value, 1.82. Anybody got it? Anybody got it? You have to open your eyes wide. 1.82, 1.82, 1.82, 1.82, 1.82. Anybody got it? I have seen something. I don't know whether you have seen what I've seen. Anybody who wants to answer that? Who wants to answer that? You got it? Got it? Any hand? Any hand? Yes, Kwesi.
We are looking for 1.82. But from the table, we have 1.81 and 1.
We actually have 1.812.
1.812 and 1.833. From my indication, 1.812 is there.
Yeah.
And we are reading from it's a two-tail hypothesis. So my p-value will be 0.1.
Yeah. You see, if you track, that's good. If you track that 1.82 or 1.83, they're all on the same vertical line. So, in fact, that is not your focus, is it? Your focus is what they are giving you. And whichever one you choose is giving you what? 0.1, which is 10%. And so, when you trace it, when you trace that 1.82 or 1.83, they are all on the same line, and that will take you to 0.1 for the two tail, 0.05 for the one tail. But we are not doing one tail, we are doing two tail. So, it is 0.10. Our p-value is 10%. Our p-value is 10%. No left 10, no right 10. It's just 10%. So, what do we conclude? Do you remember the conclusion for the p-value? When do you reject the null hypothesis? When the p-value is what? Bigger than the alpha. When your actual mistake, you remember this p-value is your actual mistake. So here, your actual mistake is what? 10%. You are expected to make how many mistakes? 5% mistakes. Now you have made what? 10% mistake. Can you reject what the guy is saying? No, you can't, because you have made too much mistake in yours. And so the p-value, because it is bigger than the alpha, the level of significance of 5%, we will again reject the null. Sorry, we will again not reject the null hypothesis. Please remember, if your calculated tabulated approach did not reject the null hypothesis, your p-value approach should not reject it. You can't go and use this approach, it will reject. Then the other approach will what? Will accept. No, you don't do that. They must reinforce each other. So let's go to a conclusion for that. A conclusion now is going to be this. The figure falls between 1.82 and 1.833, just as you did. Either way, you get 0.1 at the top, as it is a two-tailed table. You see the way my slides are very easy to read, and I even write at the top for you, as if I'm there in your room studying with you. And either way, it is a two-tail. So you get 0.1. This is 5%, because searching for it is not a small thing. But you just putting the 0.1 down alone tells me that you've gone through a lot of search, isn't it? What a joy. Conclusion. Since the p-value of 10% or 0.1 is greater than alpha, which is 5%, we don't reject the null at the 5% level of significance. So what is your conclusion? Should we buy the company or you don't buy the company? You will buy it. In fact, the first approach said it. Nothing prevents you from buying the SME. What a joy! What a joy to start the ball in this way. So that is it for the example 1. Now let's look at example 2. The example 2 is slightly tricky, just slightly, but you see that it's not too much. So let's look at example 2. We are going to read the preamble, understand it in total, and then we can now put that to the fire. Remember the steps in hypothesis testing. State your null and alternative hypothesis. Write the variables you need down. Calculate your test statistic. Find your t-critical or your tabulated. Compare the two. Use the calculated to find the p-value. Use the degrees of freedom and the alpha to find the tabulated. Compare and conclude. So those are the steps. Let's look at this preamble. Who will read for us? Who will read the entire storyline for us? Read with all joy, with pomp and page entry.
Example 2. Diufiasem, a tomato grower, has developed a new variety of tomato. He claimed that the average yield per plant is at least 4 kilograms of fruits. A gardening magazine tests this claim by growing some plants and measuring the yield. Obtain 0.69 standard deviation. Does this data support Diufiasem's claim? Formulate the hypothesis. Use both the p-value and critical value approaches.
Diufiasem. The way you are pronouncing it is not like a Ghanaian. Diufiasem, It's Diufiasem. Diufiasem. Now, Diufiasem grows tomato. So let's try and get it. This is somebody who is growing big tomatoes. Very big. New variety of tomato has come down to the country. And he is saying that, look, my tomatoes are big. In terms of weight, at least 4 kilograms of a fruit. I'm telling you, that means that the tomato is bigger than my head. Okay. But this is a claim. So a certain gardening magazine wants to check whether that claim from Diufiasem is true. So he's going to subject it to fire. But for you to do that, you must go and collect some samples, isn't it? So what he decides to do now is to grow some plants and measure the yield. Measure the yield, obtain the certain standard deviation. But below in this table, you are going to see the yield. So these were the yield that a magazine obtained. Different plants, and those were the different yields. Some of them are more than that of the UFIASEM's claims, isn't it? Others are below. The sample size is in here. Okay. Now let's go back to the story. We are going to formulate the hypothesis and then we'll proceed. So, formulating the hypothesis. One of you is going to help me, walk me through the formulation of the hypothesis. So, who set the ball rolling? I need to know what is inside your mind. We are going to write it down. How is it going to look like? Who will tell us? Yes, Kingsley.
From example 2, you'll notice that the claim is saying that the weight of the tomato is at least 4 kilograms. Meaning that, to put that in mathematical notation, it should be greater than or equal to 4 kilograms. And then the opposite of that would be less than 4 kilograms. And looking at these two, we have learnt that the one with the equality should have the null hypothesis sign, and then the alternative should go with the one without the equality. So this is how the hypothesis is. I've written it.
So write it repeatedly, and let me see.
Okay. So this is how it goes. The statement is saying that the weight is at least 4 kilograms, meaning that it is greater than or equal to 4 kilograms. So that will be my null hypothesis because it has an equality there. So my null hypothesis is HO is such that the mu is greater than or equal to 4 kilograms. And my alternative would be HA is such that my mu is less than 4 kilograms.
Okay. So you are very right, okay, in your analysis. H naught and then HA. I've told you, don't go with an intention of writing it like this. The moment you start writing it H naught, you are likely to make a mistake. So you don't do it this way. Rather, this is what you do. You look for the sign at least, and you were very right. At least is this sign. And opposite of this sign, which is greater or equal to, is less than. We're talking about 4 kilograms. So you write 4 kilograms there. This was the population mean. You bring your mu in front, your mu in front. You ask yourself, which one carries with this some level of equality? This one, at least. That is a null. Excellent. Beautiful. This is joyful because I can see that now you are really getting the picture, you see. But you see, all of that we learned are coming into place in here. First one gone. Let's go to the second point. We now have to calculate the hypothesis. Let's identify the main elements in the question. The main elements. Who can tell me the population mean, the sample mean, the sample standard deviation, the sample size, and all that? Master, don't stop. All of that. Tell me each one of them. Yes, Kwesi.
Doc, from the example above, our population mean is the 4 kilograms.
Perfect.
Our standard deviation is the 0.69. Now our sample mean. To get our sample mean, we are going to add these means and divide by the total number to get our sample mean.
The one in the data.
Yes, Doc.
What about the sample size?
The sample size is 10.
Excellent. I like the way you are pointing it that way. Good. That is very good. That is very, very good. So, you see, the data has been given to you there. And in that data, you should be able to count the sample size. It's 10. You're very right. In that data, you should be able to calculate your sample mean. In fact, in that data, you should be able to calculate your standard deviation. But that very one has been done for you in the story because you were told that the standard deviation is 0.69. So there is done. So your job is to find what? The sample mean. Finding the mean is a very easy thing. add this to that, this to that, this to that, this to that, and then divide all by the sample, which is 10. So you do that, and then you are good to go. So remember, these were our hypothesis. This is a typo. It should be the HA. And then the significance level was not given. And whenever it's not given, it's supposed to be what? 5%. So 5% is there. And then we have to now think about whether it's a one-tail test or is a two-tail test. Is it a one-tail or a two-tail? It's a one-tail, isn't it? Very simple, because we have one directional in both cases. And then the test we are going to use, is it a Z test or a T test? It's a T, because the sample size is what? Is 10, which is less than 30. We are good to go. So the sample mean is from the previous example we did. So the sample mean here will be what? 4. Okay. Then the population mean will be 4. The sample mean will be 3.8, because when you add all, you're going to get 384. Then you divide 384 by 10, that gives you 3.8. And then the sample size will be 10. Then the standard deviation will be 0.69, which was given to you. Alpha is 0.9. You drop all of them into this, which is what you're rather looking for here, into the formula. And obviously, you're going to get negative 0.73 as your calculator. Once you have that value, your calculator is sorted. Remember, we are going to use this calculator later to find what? The p-value. But for now, once you have your calculated, you have to find your tabulated. Well, the tabulated finding it is very simple. Our degrees of freedom. What is our degrees of freedom? 10 minus 1. What is our alpha? 0.5. So 10 minus 1 is what? 9. Our degrees of freedom is 9. Our alpha is 0.5. We are going to use that to find the calculated. So let's go to the table. We are going to use that to find the calculator. Remember, we are going to look for 9 under 0.05. Search 9. Remember, it's a one-tail this time. It's not a two-tail. It's a one-tail. So when you get it, use numbers at the top. Okay, you're looking for 0.05 at the top against 9 where they meet. Have you got it? Okay. Let me give it to one of you to tell me. Who will tell me? Who told me? Yes? Mommy, are you ready? Yes, Mommy.
From the table, with 9 degrees of freedom and alpha of 0.05 at one tail, you get 1.833.
Very good. Very good. That's it. Very, very good. I mean, 9 is there. You start moving to this side, moving, looking for 0.05 for one tail. There you go. 1.33, 1.833. 1.833. That is your tabulated. Remember, your calculated was what? In absolute terms, 0.73. Your tabulated is 1.83. So your calculated is still not bigger than your calculated. So you can see clearly. What is going to happen at this stage. Calculated is still not bigger than tabulated. So here we go. You can see that our calculated is 0.73. Our tabulated is 1.833. So we can conclude. Since the calculated, which is 0.73, is less than the 1.833, we don't reject it now. Now, this is where it becomes interesting, is because it's not about just rejecting or not rejecting the null, but it's about getting the intuition from that rejection or non-rejection. We don't reject it at the 5% level of significance. So what do you conclude? Well, the data strongly suggests that the true average yield, because it means that you are going with a guy's statement, Dufay-Sem's claim, the true average yield is indeed at least what? 4 kilograms. No problem on it. The Gardening magazine must support Dufay-Sem's claim. They have to take them to where? Lunch. You have to take them to lunch. Because normally you just support that person's claim. And then, now there is a difference. What the guys claimed was 4 kilogram. And then when we calculated, we had a mean of what? 3.84. The difference is equal to 0.16 kilogram. That difference, is it due to chance? Is it by chance? Is it just by chance? It is by chance. You see, if the difference is so wide, then you would say that it's not by chance. So this story of is it by chance or is not by chance could be very tricky. Okay, the difference of 0.16, because you are holding on to that guy's claim, even though you had a bit of difference. Okay, you had a bit of difference. You had 3.84. He is claiming that is 4. So you've got a difference of 0.16. So you don't say that, oh, but I'm telling you, your 4 and my 3.84, there's a big difference. There's a difference. So I can't go with your statement. You don't say that. Because the hypothesis clearly is telling us we should what? Support him. So if we are to support him, but you still had a difference, then the difference is what? It just came by what? By chance. We can't say that the difference is a big thing to go with. It's just by chance. Okay. So now we can now conclude in that way. But this is using the critical value approach. Let's use the p-value approach. What will be the value, the p-value? You remember you have to drop the 0.73 into the swimming pool. Let's drop that and search and see the closest value. So that is our last exercise now. Let's drop that. Let's drop that value 0.76 into the swimming pool. There you go. 0.76, 0.73. Drop it here. Boom, like that, and start combing. Search for the value closest to 0.73. Which value is closest to 0.73? And then when you get the value, and be sure it's closest to 0.73, then you read the p-value at the top. Don't forget the tail. Have you got it? Have you got it? Have you got it? Okay, who will answer that for us?
Okay, 0.73 is actually not on the table, but it's between 0.727 and 0.741, which when you trace is 0.25.
Good. So points, I like the way you said 0.73 is not on the table. Because if you start going looking for 0.73, it will be 2020. Okay. But it is between 0.727 and 0.741. So clearly we're somewhere here. And interestingly, watch, they are all always on the same vertical line. So when you trace it up, you are going to get a one tail, which is 0.25. 25%. Way bigger than the 5%. So you are expected to make a mistake of 5%. You made a what? 25% of mistake. You don't have to rely on your research. Just focus on what the guy is saying. No wonder we accepted what the guy actually put forward. Wonderful. So you can see it falls between 0.727 and 0.741. The tail is a one tail and you have 25%. Conclusion. Since the p-value of 25% is greater than 5%, we don't again reject. Remember, the p-value approach will always support the critical value approach. And then we can conclude. The true average yield is not below 4 kilograms of fruit. What a joy, what a joy, what a joy. I have enjoyed it. I don't know about you. If you haven't enjoyed it, go and drink. Okay. When you drink, you cannot get it. I'm giving you practice questions when you get home. Practice it. A shareholders group lodging a protest claimed that the mean tenure of office of the current CEO was not below 9 years. You are now to use a story and formulate a step-by-step hypothesis. And these are the questions that go with that. Do that. The second one is a travel magazine. Practice it. Please enjoy doing it so that you can come here and come and show us how you did it. And then do that second one. And then the third one, well, I'm loading you because I want you to swim. Because when you swim, then you can now get an A. According to the label on packets of popcorns, there should be 25% of popcorns in every packet. So go and test this. The next time we shall go into this session, which is parametric hypothesis, 2 samples. Remember, we've done 1 sample. Next time, you're going to have 1 sample and another 1 sample so that you have 2 samples. If 1 sample was easy 2 samples will be easy. If 1 sample was not that easy, it means you have to sit up and then you can now enjoy. Remember again, drink deep or taste not the pure and spring. There shallow drought intoxicate the brain, and drinking largely, like you have drunk today, will sober you again. Thank you very much for listening to me. I will see you very soon.